I'm going to go through the scripts right now for the maths, and I'm going to use three examples of three different people that I think teach it incredibly. The first one being Arturo Tedeschi, the second one being Daniel Kristev, and the third being Raya Isa, who has given up all of her scripts online for free or through GitHub. I think it's just in the Rhino. It's definitely worth going through to get to the essential mathematics. I'm going to show you an example of those scripts that come. All these scripts come for free online. You just need to pick them up. And what's wonderful is those scripts are written in C#, Python, and in VBScript. So I'm just going to take a look at a few examples. First and foremost, since I started with, and you can see here I have some geometries, we are going to be looking at a few of these as we go. Most of them won't be that necessary, but the script tools that you're going to look at are the evaluate, the expression, the C#, Python, and VBScript. Right off the bat, Tedeschi in his book AAD, and I've made these scripts out of that book, and I've chosen a couple which I think are worth looking at. We basically have, if I showed an example of this, make a parabola in a very, very simple form to a script in the expression node. You simply have your variables that come in, and I have a range of numbers that run between 0 and 18 in this situation, and you apply the function to it. So x comes in as that series of numbers, and you apply 1/6 times x squared to it, and that generates a series of points which can be interpolated. And what I'll do just briefly to show you that is show you that that's a very small, actually I think it's a very small script. There it is. Basically that's, and then it mirrors that line. So it's a great use of what I wanted to show, and Arturo Tedeschi does that very well here. Very simply with an expression, you bring in x, a series of numbers, and you apply the function to it. I don't actually use those function nodes, and I prefer to leave things on the evaluate to dealing in letters and numbers. The second script that I pulled from Arturo Tedeschi is two ranges that are holistically joined. And then the function is basically applied to x into y. And this is going to make a surface, I believe. Hang on a second, I'll have to pull it up. I don't have it on preview. Let me see if I can get there some data. The ranges, the points, there they are. These points are generated from a holistic pattern, and then you're applying a script of x squared plus y squared, the negative of that divided by 4 plus 4, and that moves it in a direction. You have an ability to move that by x and y. And so you write a function in a panel tool, and you put it into the expression node, and then you apply it in the variables. Relate to that, and you end up making a surface. Another one of Arturo Tedeschi's simple scripts. What I'm going to show is I use the expression, the evaluate tool, in this way that you're actually dealing with Booleans to start, which is actually very nice. Think of an expression, and you can check things as x being greater than something or x being equal to something, and you'll get the Booleans 0 and 1. A great way to get into culling out patterns and using Booleans to move geometries. Then he takes a circle, and he does a scale on it multiple times. I think I generated that in this script. And then for anyone that holds a radius larger than 8, it will extrude it. So you can see it doesn't do the ones in the middle. And if I hold down shift, you'll see it doesn't loft those other ones because they don't have a radius of 8 or more. 1, 2, 3, 4, 5, 6, 7, 8, and then 9 is larger, so the integer value lets those loft. And yeah, so very simple. And then really what the evaluate tool does well, and to lead to that, he uses a couple of examples that these are Arturo Tedeschi's scripts, basically concatenating something. Think of this as a function. Think of this very similar to this node, the evaluate node, but basically it's evaluate node set to and, which means some of the it will concatenate those two texts, same way that it does this. If x is greater than 12, it will put that in as a panel. It doesn't have to be, I mean, it will say whatever you put in there, change to it. Then here, if, this is a conditional, uses an expression node. There's a wonderful way of writing it, and it understands that. What's nice is you don't have to change in the expression node when you're dealing with Booleans or your conditionals. You don't have to actually take it and go in and right-click and make this say x. You can actually let it remain variable x, and that's a little subtlety I noticed while going through here. So a little tip. So as I go through there, if x is greater than 5, and here it is greater than 5, then it'll say hippie, and if I put it less than 5, you'll see it switches to null. And actually, something happened. Oh, no, I guess I can't. I guess what I said was not true. Let's take this back to an x variable, and let's take this one back to a y variable, and let's see if that has an effect on bringing this in, and that should allow me to do it. There you go. 69 comes up because x is not less than 5, and it goes back to hippie if it's more than 5. So you're using the expression nodes, and I use the evaluate nodes, not the expression nodes. I use that whenever I'm dealing with this type of Boolean or word. So x contains 4, and then I wrote it a bunch of numbers, and if it does, it'll say true, and of course it does because there's a 4 in there. And I think it actually goes so far as to contain 4, even if it's in 34. So that might be interesting to check that out. And once again, the variable, I kept the variables here, and it seems to be running. Other operators create a line in Rhino, and I think the line here is right here, and it says basically, is that a line? And because that actually has line in it, when you look at a line and put it into a panel, it says line, and then you bring it into here and it says yes. And that's a case that you can actually take a panel and put it into there as opposed to going back to the line and putting it in. Because if you put the line in, it would fail. It's reading the panel and looking for the word line. You could change this to poly, and then if it was a poly line, it would come up true. Now, that's a lot of examples that are Arturo Tedeschi that come right out of AAD. I've used that to learn quite a bit, but the other guy online that I've really come back to again and again and again is Daniel Christow's work, and he has some great ways of working geometries. All these are his scripts. They're worth having a look at, dealing in distance, and he writes within the expression node all these wonderful scripts. So it works very much the same, but as you input, instead of x and y, he's bringing in w and t. He's writing this equation directly in the expression node, and it's so much worth going into the expression node and seeing the functions you can actually have access to. And it will tell you when you have no syntax errors. So definitely you want to be using the expression node probably more than the evaluate node, unless you've got a pretty good understanding of what you're doing and it's leading you to coding. So here's another couple of examples of putting them in, and then this generates a pretty wild three surfaces on top of one another that you can use. So very nice. And I've used that in my mass addition, mass multiplication, another video. I keep coming back to those. And I keep all these awesome scripts by Tedeschi and Christov to use and apply to my geometries. I don't put them in clusters. I leave them there so I can pick and choose from them. The last example is really just a couple of a very simple example of going into Raya Ice's work called Essential Mathematics for Computational Design, 4th edition. Just amazing. So if I go in here and I take a look at Pi, and they've written a node into Python, the way Python scripts works, there's a lot of details here. You'll have to go to my Python chat section to see it, because you're going to want to go in here and be able to get the right access listed and get the right hint type on everything. This is a float, so it has to be put in there. But I'm just going to move my Pi looking at that node, and you're going to see the geometries I input behaving. And in the same case, pulling out a matrix. So they use a nice scripted code that when you double click here, it'll open up what slowly I want to know more and more about, and that happens to be very specifically writing in Python. And so in that importing Rhino, you're going to go in and read right through using the keywords that work in Rhino script for Python. You generate it, and you have your inputs and outputs, and you write your own node. Now consider every other node has been written somewhat in C or in Python or in VB script to generate it, but you are actually making your own nodes. So you have your inputs and your outputs. Really nice examples. And then in the same breath, you have, say those geometries are here. You can have those input geometries, and even though these have been preset, they're not put to pi and then rotated by a slider. There's a great example of that script being written here, and there it is again. Importing Rhino and writing it in Python language, and if you're familiar with that, you want to be able to write it. But my thing is go on solo learn, look at a few languages. You may have to go somewhere else for VB script, but take a look at how that's written. And Python's quite readable. You'll see a little more complexity as you bring up your C script, and you'll be like, well, there's the same thing happening, but this is if I chose or had language, and you can see the same script actually being written, but it has different indications of comment lines with this hashtag as opposed to the double backslash. You've got to change a little bit of obviously what's happening, semicolons versus colons in setting functions or iterations or conditionals. And then the last one is the VB script if you're interested to take a look. And you can look at them all. I would say print them out. I would say, at times I'm not going to want to learn to write all of these and memorize and write in every language. But logically, I want to be able to follow and read this. I do want to be able to debug it at some point. But chances are the scripts that I'll be using can be found online and cut and paste into my nodes to actually do additional things. And I may go farther into this, but right now, as a beginner, you'd be starting out going into certain scripts, and you'd be going in here and going, like say you had pi and you wanted a factor, you could go and take the expression start to type, which technically are expressions in the simplest form. Like if I said that was actually multiplied by 2, I could say x coming in times 2. So this may be where you're beginning. And this kind of starts with vexing and working in Houdini, which I found you're going up into the parameters and changing things and getting everything tied together in a way that you pull wires in Grasshopper. But there's something that now it's changing the rotation. As I go here, I might have to zoom back out to find it. It's doubling the rotation, so it's going twice as fast just because, and it'll go 2 full pi because I had set at 1 pi, but now it'll go 2 and do a full rotation instead of half. And you can always just take that off by going back in expression. So that's the simplest form of what you would be doing. But think about it. And honestly, go online, get the free things, look at all, buy the book AAD by Tedeschi. Look online for examples that are free in small snippets. I don't feel bad. I definitely don't think I'm infringing on anything by using simple scripts that touch on ranges and points and interpolated lines. But it is nice to have a look at what some logics might be that you never thought about on the basic of scripts. And once again, Daniel Christo's work is outstanding if you're a math-minded person. Everything he does really gets you hard and fast into expressions right off the bat. And he does multiple things. And like I said, he does mass multiplication and addition with this stuff. I keep coming back to it. And I actually prefer these landscapes, which are just absolutely fantastic to generate anything that I might want to bring to a render. Multiple layered, glazed, transparent glass bases. And in the same breath, you can swap things out if you didn't like that one. You find another way of switching it. Just set this one up as the multiplier, and there you go. You have something else. And honestly, you have 3 scripted things being used right now. The last one, Rhino, you've got to print it off. It's something like 100 pages. I'm going to hold it up. You want to go right through it, and you actually want to check out if you want to know about expressions and the maths tied to that. You can go over the easy stuff to start. But you're going to be looking into 3 sections. The first one's just the maths or operators, then it's matrices, and then you're getting into you're getting into some really complex things that are happening. Of course, all those scripts are free. I would have them available to you, and if I have to pull up any, and I want to have them, I have them at a drop of the hat. Rhino matrices, and you just get everything you need. And pick and choose. Know your scripts and know where to find them. Thanks very much for watching. There's so much I could do on this. You might want to watch the series online on Python to begin with, let alone just essential maths. There's so much to pull out of this computational design from Rhino. Thank you for watching.